Welcome back to main stage for the last afternoon session. Excited to introduce Hilmar Orth from Gelato with some exciting updates. So take it away. Thanks.
Hi, everyone. I think the audio is working well. Thanks a lot for coming to today's talk. My name is Hilmar. I work at a project called Gelato. And Gelato aims to build the backend that empowers the world to run smart contracts, and what that means is, I think I will get into that later on. But specifically today, I want to touch upon a new service that we've been developing that is helping projects to leverage off-chain data and computation to augment their Web3 applications. And yeah, this is me, and I want to give a quick shout out to Gnosis as well for inviting us over. We actually gave our first talk about Gelato exactly 3 years ago here at DappCon as well. It was actually before we had our first version live, so it's definitely awesome to be back here to talk more about what we've been up to since then. From an agenda point of view, I want to start sort of like high level and then go a bit more deep into certain examples. We'll also show some code, but I want to start with sort of, okay, where are we today in terms of Web3 adoption? What has changed since I gave my last presentation here 3 years ago? And then touch upon why we are not at mass adoption yet in Web3. And then touch upon the current problems, especially from a Web3 developer experience, that contribute to that. And then how we at Gelato try to help projects overcome these limitations. And then go deeper into this new service that we have developed over the past weeks, which is the off-chain data and computation service that I mentioned in this very easy-to-read title of this presentation. So yeah, starting off sort of high level, where are we now in terms of Web3 adoption? What has changed? And I think going back to like 2019, and at the far left, you can see that in the bar charts right there, that the volume and the transaction volume in Web3 has increased, of course, significantly. There has been a lot of TVL flooding the system, a lot of trading activity happening, and it sort of peaked in Q2 2021. And that has been sort of going down, but of course still considerably up compared to where we were back then. And what I think is super interesting here is that the sort of line chart actually shows the number of transfers and transactions that is happening. And it actually has been it increased considerably still since the market peak of Q2, and only sort of recently saw like a 10% dip from the all-time high. And this is mostly due to the fact that right now we don't only have DeFi applications anymore. It's not only trading, it's not only lending, liquidations. You have, and you see that on the sort of left side, you have brands coming in, you have NFTs getting adoption, games getting adoption, and even though trading volumes and asset prices might decline, usage is actually still very high. And this is very positive, and 3 years ago, that wasn't the case at all. There were only DeFi applications, and now there's a whole new set of use cases, which is exciting to see. But if you sort of look in the long term, where are we when we compare Web3 adoption, and this is now Ethereum's user base, to that of the internet? There you can see if we make an assumption that an active user on Ethereum is an address that is transacting on Ethereum at least once a month, which of course is a very optimistic way of seeing users on Ethereum. Then what is sort of visible is that only 0.1% of the entire world's population is actually using Ethereum, and I would arguably say much less than that, because an address is not a user. And that means that we are sort of on the same progression line as the internet was in 1995. And basically what this should tell you is we are still very early. It will still take some time. It took the internet another 10 years to reach the first 1 billion users. I think we all hope that it will go a bit faster for Web3 in general. So why are we not at mass adoption yet, right? I think there are a bunch of reasons, of course. Some of them are regulatory. But I want to focus more on the user experience and the technical limitations of today's systems. And what I would like to argue is that there are really like two foundational things that is currently preventing that from happening. And first is that public blockchains today are still incredibly bad in terms of user experience. If you ask your grandparents to try out this new dApp on Ethereum or even on Polygon, they will still probably not be able to do that because they have to set up a wallet, buy the network token, deposit it into the wallet, set a gas price, resubmit a stuck transactions, and all of these things that just make it very hard for regular people that are just used to clicking buttons and stuff working to function. And other than that, and other than the user experience, you also have a lot of limitations in today's systems that make it so that you need a lot of external services to actually provide a scalable, feature-rich, and user-friendly Web3 experience. And two of the major reasons here are that smart contracts are actually not smart. They are quite dumb. They only store certain logic and state, arguably, and that logic can define how that state can be manipulated. But they don't actually manipulate it by themselves. They rely on external actors to actually facilitate their state changes. And they cannot communicate with any sort of external data. And if you look at what data is available on chain right now, it's super limited. And most people in the world don't care about crypto asset prices or interest rates. They want social data. They want gambling data. They want sport data. They want all sorts of data that you don't have on these chains right now. And so what projects had to do in order to actually bring it and provide the users with these functionalities, they had to build and run and maintain a lot of custom backend server infrastructure for each specific application that they were building, which was not only unscalable and very costly for them, prohibiting a lot of them from actually doing that, it also created single points of failure and sort of your dApp not being decentralized anymore. And this is, if you zoom out, this is sort of like the Web3 middleware stack. There are arguably a bunch of other services like storage and stuff that is not listed here, but this is sort of like, it's not only the smart contract and the user interface that you have to care about. You have to care about the automation, arguably called like keepers. You have to talk about making your application gasless, relayers. You have to talk about enabling your application to be off-chain aware, where oracles come in. And then, of course, this is the write side. On the read side, you need to index all of these information that you have and provide them to not only your UI, but maybe also others. So there's a bunch of stuff you have to do, which is not just smart contracts and user interfaces to build good applications. And this is sort of what we at Gelato focus on. We try to provide all these missing services that are not natively supported on public blockchains and smart contracts today, and provide them to developers in a cost-effective, decentralized, and scalable manner. And basically enabling them to build automated, gasless, and off-chain aware applications. And users of these services are end users that want to programmatically interact with smart contracts themselves, for example, claiming like weekly synthetic rewards or something. Then dApps or protocols themselves that need certain processes to be made gasless or automated or off-chain aware, and then also DAOs, which is also sort of like a protocol. It's a smart contract that you need to interact with. And we do that via our services that we call services, and these are our automate, relay, and fetch service. This is sort of like what we call the augmented Web3 stack. You got smart contracts, and then you got individual services that do certain parts where the automate service is basically process automation, and use cases there are compounding of yield harvesting vaults or algorithmic stablecoins such as Ohm being rebased and inflated and deflated every half an hour, limit orders on AMM such as PancakeSwap or so that are executed, or just lending market operations like debt ceiling updates in MakerDAO that have to happen over and over again, and then even gaming projects needing to automate the closure of NFT renting agreements or all these sort of things. Whereas Relay is more focused on just making processes gasless and efficient, such as like a Connex or a Nomad, integrating it to relay transactions across 18 different EVM chains without having to build like infrastructure for 18 different EVM chains that will take you probably alone like a year to do from scratch. And now also what this talk will be more focused about is this sort of off-chain computation service, which we now released in private beta. It's not public yet, and this just enables a whole new array of use cases that developers can just easily build up without having to deal with all sorts of the backend complexities. For example, automated liquidity management strategies, which require access to volume data, price sentiment, different indicators that traditional market makers use and now will apply on concentrated AMMs such as UNISWAP v3, or games that need to decide based on off-chain things who will win a race, for example, a whole like order book experiences and many, many more use cases. This is sort of how Gelato works under the hood. We got two main actors in the system, and we have on one side validator nodes, on the other side executor nodes. What validator nodes do is basically they have to stake the governance token of the system, GEL, and what they do is they are running these sort of microservices within their client. And these are, for example, the fetch or the automate microservice. And what these do is they run certain scripts, and these scripts determine when they should execute a transaction and what data they should use to execute these transactions with. And depending on where this data is coming from, sometimes it can be verified on-chain, sometimes it cannot be verified on-chain, and then if it cannot be verified on-chain, then you need to come to like an agreement on, okay, what data should be used here, right? And then you have multiple nodes with different stake, and then you need a certain stake threshold to determine which data should be used to then execute the transactions. And then this is where validators have to gossip between each other this data to find out if they come to an agreement on it. And if they do, they will basically sign off of that data, send it over to these executor nodes, and these executor nodes are basically connected to 18 different chains, and they get the transaction mined reliably and efficiently on each of them. And then a transaction is basically be placed, and it will hit the smart contract of Gelato, the on-chain protocol that does a certain validation of different things. Then a transaction will be routed to a protocol like PancakeSwap to MakerDAO or Uniswap, and then be mined on-chain. And then this is sort of like the end of the life cycle. And how does this sort of fetch service work in detail? And if you basically thought about, okay, I need to fetch certain data from APIs, and I need to automate and send transactions programmatically based on them, then this will be very relevant for you. And if you have ever used the graph, for example, then you will find it a very similar developer experience. So what you will have to do is you have to write what we call an off-chain resolver. And an off-chain resolver is basically an assembly script file, and I will show you one in a second. And that assembly script file can read from the chain, and it can do any sort of arbitrary API GET requests to external servers. And from there, you can get data. And that data you can do computation on. And on that data, you can then see, OK, when should I execute a certain transaction? And with what data should I execute that transaction? And we can go into like examples later where you can actually be a bit more granular in terms of what security you actually want around that. And then what you do is you compile down this assembly script to WASM code, and then you deploy that WASM code to IPFS or like an RVev or something. And then you have to go to Gelato. There's a smart contract where you can call a function where you can create a task. You can put that IPFS hash, for example, in that transaction, and then an event will be emitted, and Gelato nodes will be able to query that script, and they will load that script into like a secure execution environment and run it for you, and then execute these transactions on your behalf. This is how it roughly looks like. I think it's big enough from a text perspective. If you look at the bottom, basically, this is where you tell Gelato, first of all, if it should execute for you, or if not. If can exec is true, then Gelato should execute it. And the exec data is basically the data it should use. And the data that is defined above here is just a smart contract function that you would like to encode. And the sort of last argument of that argument array, the swap data, you actually see one line above, is generated by the getSwapData internal function, which does an HTTP request to, in this case, a DEX aggregator that will then be used to execute a limit order. And for example, if you go one line above, you see that in this case, we actually don't want the transaction to execute because the amount that we determined out of this API call that we would get out of the trade is actually not sufficient. So we would like to only execute the trade when we get enough amount out. And this is how the getSwapData, this internal function, will look like. You have an API that you can define. You could define any sort of API. And you can do a GET request to that API and query it. and then you get an object returned that you have to parse, and then you have to return this data that you want. And then, of course, you can define certain edge cases that you can then also return, and then you actually see on our web app the logs of what these nodes are seeing in real time and can debug it and see if maybe some APIs are failing you or whatnot. And it is really up to you what sort of APIs you use and how secure they should be. And then once you did that, the only thing you have to do is you have to run the yarn deploy command that will compile down the assembly script to WASM, deploy it on IPFS, and then you get like this nice IPFS hash out of there, and then you have to run another command or go to the web app, put in that IPFS hash, run yarn create task, and then Gelato nodes will load in that logic at runtime and run it for you, and then you are sort of sorted, and it just works. One cool thing that I want to focus on here a bit is that what this actually enables you to do is sort of like a plug-and-play and modular data integrity system, where it's sort of up to you what security you want around the data you're fetching from these APIs. So let's say you want a certain first-party blockchain network. You want a first-party Oracle to actually return you the data of like a CoinGecko price feed, right? So you can go to like a CoinGecko server where they provide you with a signature on that data, and you could use that to not have to rely on Gelato's trust assumptions to then take that data and then submit them on chain, where you then validate that signature of that particular server, for example. Or you can use these sort of next generation Oracle networks that don't just aggregate API requests from multiple nodes and then just dump them on chain every 10 minutes, but they actually aggregate them and then put them into like an IPFS or an Arweave, where then anyone with an HTTP request can take them on demand and only get them mined whenever they need to get them mined. And that way, you can basically define any sort of arbitrary conditions upon which you want to get that data from an Arweave that is signed by whatever validator set you feel comfortable with, and get it on chain. Out of the box, we won't have our own validation set at the beginning, but in the near future probably would also want to provide that. But you can literally plug in any sort of system you want. You can also have your private server that has an endpoint where you sign messages to make sure that the data has integrity. And then once this data is deposited in an IPFS or Arweave, Gelato will fetch that data via the API, run the computation on it, and then submit it to whatever chain you want to have it submitted. So you need sort of like 3 parts here: oracles, signed data, storage, and then the off-chain computation execution pillar. Yeah, and this is sort of like a small overview of the different projects that are already using us today. If you're interested in these sort of things, definitely let me know. You're also in good hands and in good company. This sort of like fetch off-chain computation service is still in private beta right now. So if you would like to give it a spin, let us know in the chat or here, and we can give you some access, and you can play around and see if it would work for your particular use case. And yeah, that's already it. We've got an awesome Gelato booth outside, by the way. It's the best gelato in Berlin, so you should definitely try it out. And yeah, thanks a lot for listening. Are we doing questions? Okay. Is there any question? Was there a question? Yeah.
Thanks so much for the talk. My question is the executors. There's a whitelist right now. Are there any plans to get rid of that in the coming future?
So right now there's a whitelist of executors. Why? Because right now we want to enforce certain ways of how transactions get actually submitted on chain. That is a bit hard to enforce within smart contracts. For example, we want some use case to only submit via flashbots on Ethereum because there's a lot of risk of front-running a sandwich attacks, for example, for a lot of the protocols that are using us. So And that's why there's a whitelist right now, and different node operators are operating these executors. But this is actually, in our decentralization roadmap, the first part that will be fully made permissionless with staking soon. And then you have the validation system, which is a bit more complex to make fully permissionless without a whitelist. But this, I would assume, sort of like in a Q2, Q3 next year should also be. The goal is to be completely fully permissionless without any whitelist, obviously. Yeah. I think we're good.
Cool.
All right.
Yeah. Thanks, Hilmar.
Thanks.
Yeah.